This is a quick video from Professor Gustaf Olsson of the Lund University of Sweden, who has researched and published widely on the Water-Energy Nexus. This is from the Water for Liveable and Resilient Cities from MONASH University by Rob Skinner. And this is week 2, Integrated Urban Water Management, IUWM.
So far I've talked about the energy you need to deliver the water and to clean up the water. Now we'll talk about all the water that you need for energy delivery. If I start with oil, you need water to extract the oil from underground, and sometimes, especially in non-conventional oil, like oil you get from the tar sands in northern Alberta in Canada, for example, or oil that you get from shale oil using hydraulic fracturing, needs much more than the traditional crude oil. We are talking anywhere of 40 liters of water per liter of oil in traditional conventional oil, and up to several hundred liters of water per liter of oil in the non-conventional oil. In other words, the price in water is very high. Looking at the biofuels, we also can talk about thousands of liters of water per liter of ethanol, for example. And if that water is pumped from groundwater for irrigation instead of rainwater, then the use of biofuels is certainly not sustainable with respect to the water, because we very often use fossil water from the groundwater sources in order to get the water that we need for the energy. We also need a lot of water for cooling our thermal power plants, nuclear power plants or coal-fired power plants. They all need cooling. Now, if they are located at the coast, you can use seawater or brackish water, but very often the power plants are located inland, far away from the coast, and you have to use either rivers or lakes in order to cool the water, cool the thermal power plant. And of course, again, the climate change is making the water either warmer, so the efficiency of the cooling is not so good, or you don't have sufficient amount of water in the river. So we are talking both about water temperature and water flow available. Finally, about hydropower, we think hydropower is a very clean water source. However, there is a big consumption of water also in hydropower, because when you collect water in the dam on top of the hydropower dam, then there is a lot of evaporation. And in warm countries, this evaporation can be considerable, many times higher than the evaporation that you get from a thermal power plant, for example. And the worst example in the world is actually using 3,000 liters of water per kilowatt hour of electricity from a dam in Africa. So there are many considerations about how much water is needed in order to give us the energy that we need in terms of electrical energy, or in terms of, let's say, petroleum energy for transportation or many other purposes.